Hello and welcome to my channel. In this video we will be looking at inferential testing, which you need to know for AQA A-level psychology in the subtopic of research methods. I hope you enjoy this video and find it helpful. Let's get started. Statistical tests are used to determine whether a significant difference or relationship between variables exists or whether it has occurred by chance, and whether a hypothesis should be accepted or rejected. This is discovered using the calculated value, the result obtained from the statistical test, and the critical value, the numerical boundary that stands between accepting or rejecting the null hypothesis when a hypothesis is being tested. The critical value is worked out from a table of probability values and depends on various factors, whether it was a one- or two-tailed test, the p-value, and either the n-value or the degrees of freedom value. The following table can be used to work out which statistical test will need to be used to work out whether there is a significant difference or relationship between variables. Rule of R: if there is an R in the name of the statistical test, the calculated value has to be greater than or equal to the critical value for the result to be significant. If there is no R in the test's name, then the calculated value has to be less than or equal to the critical value for the result to be significant. Type 1 and Type 2 errors. There are two different types of errors psychologists can make when conducting psychological research: Type 1 and Type 2. Type 1, optimistic, error is when the null hypothesis is rejected when it is true and the researchers claims to have found significance in the result when the results were caused by random variables, a false positive. There are several ways to reduce the likelihood of Type 1 errors. Lower the significance level. Alpha. The significance level is the threshold for determining whether a result is statistically significant. By setting a lower alpha level, for example, changing from 0.05 to 0.01, you reduce the likelihood of making a Type 1 error. This means you require stronger evidence to reject the null hypothesis. Increase sample size. A larger sample size can provide more reliable estimates and reduce variability in your data. This can help ensure that any observed effects are more likely to reflect true differences rather than random chance, thereby reducing Type 1 errors. Use a more rigorous statistical test. Some statistical tests have built-in mechanisms to control for Type 1 errors. Using tests that account for multiple comparisons or applying corrections, like Bonferroni or Home-Bonferroni, when conducting multiple tests can help reduce the risk. Pre-register your hypotheses. By pre-registering your hypotheses and analysis plans before conducting your study, you can help avoid the temptation to look for patterns in the data that might lead to a Type 1 error. This adds a layer of accountability and reduces the likelihood of data dredging. Conduct replication studies. Replicating studies can help confirm findings. If results are consistently replicated, it adds confidence that the original findings are not Type 1 errors. Type 2, pessimistic, error is when the null hypothesis is accepted when it is false and the researcher claims to have found no significance in the results when there actually is one, a false negative. There are several ways to reduce the likelihood of Type 2 errors. Increase sample size. A larger sample size increases the power of your statistical tests, making it easier to detect true effects. This is one of the most effective ways to reduce Type 2 errors. Increase the significance level, alpha. While this can increase the risk of Type 1 errors, raising the significance level slightly, e.g., from 0.01 to 0.05, can help reduce Type 2 errors by making it easier to reject the null hypothesis. Use a more sensitive test. Some statistical tests are more powerful than others. Choosing a test that is more sensitive to detecting differences can help reduce Type 2 errors. Reduce variability. Controlling for extraneous variables and ensuring consistent measurement can reduce variability in your data, making it easier to detect true effects and, thus, reducing Type 2 errors. Conduct a pilot study. Running a pilot study can help you identify the effect size and variability in your data, allowing for better planning of your main study. This can lead to a more accurate estimation of the necessary sample size and improve the chances of detecting true effects. Probability and significance. Significance is a statistical term, which refers to whether a result is likely to be true or if it occurred by chance. If the result is found to be significant, the null hypothesis is rejected and the alternative hypothesis is accepted, and it is concluded that there is a high probability that the observed effect or relationship is not due to random variation, indicating that the findings are meaningful and can be relied upon. Probability is a calculation of how likely it is for an event to happen, where 0 equals statistical impossibility and 1 equals statistical certainty. A significant result is one where there is a low probability that chance factors were responsible for any observed difference, relationship, or association in the variables tested. The result from the statistical test, observed value, would be compared to the critical table value at the 0.05 level of significance. The level of significance in psychology is p less than 0.05 and is the conventional level of probability employed by psychologists to balance the risks of making a type 1 and type 2 error. This means that there is a less than 5% likelihood, probability, that this difference occurred by chance and something other than the experimental manipulation of the 4, and there is a 95% confidence that the research hypothesis and any difference or effect is due to the variables under investigation. The level of significance will be p less than 0.01 if there is any risk attached to the research, like a human cost, or if the topic is sensitive, e.g. clinical drug trials that could affect an individual's health. This means that there is a less than 1% likelihood, probability, that this difference occurred by chance and something other than the experimental manipulation of the 4, and there is a 99% confidence that the research hypothesis and any difference or effect is due to the variables under investigation. How to conduct a sign test. Step 1. State the hypotheses. This includes both the alternative and the null hypothesis. Step 2. Record data and work out the sign. For example, the sign will be negative minus symbol if the value has decreased in the second condition, but positive plus symbol if it has increased. If the value has stayed the same, this value will be ignored and the n adjusted to exclude it. Step 3. Find the calculated value for the sign test, S, which is the number of times the less frequent sign occurs. Step 4. Find the critical value of S. Use the calculated n value, which is the total number of values with the ignored values excluded, and p less than or equal to 0.05, which means there's a less than 5% probability that the results occurred by chance. If S less than or equal to critical value, reject the null hypothesis. There is a significant difference. If S greater than or equal to critical value, accept the null hypothesis, there is no significant difference. Step 5. State conclusion, whereby you refer back to the hypothesis mentioning the 4 and dv and support your conclusion with the exact values of the critical value, S, n, and what p-value you used. Using a sign test will allow the researcher to decide whether differences in helping behavior are due to chance factors or a real effect. Thank you for watching. If you have enjoyed this video, please like and subscribe for more content like this. Bye.